Hi, welcome to Raw Math. Today I'm doing a series of videos on lines. And in this video, specifically scatter plots and line of best fit. Okay, so I have this table of values. It has to do with active woodpecker clusters in the part of DeSoto National Forest in Mississippi. And we have specific years that the data was collected. So the first thing I'm going to ask before we even get into graphing is, what are the characteristics of a line of best fit? Because I find that this gets to be confusing. Really, there are two. The first one is that the line splits the data. And it splits the data evenly. The second is that it goes in the direction of the data. This is also very important. Once we get our scatter plot, I'll talk about this a little bit more. Alter the input to make it more usable. What that means is this point right here is 0, 0, and I wouldn't, getting to 1992 wouldn't be an easy to read graph. I like having things with small numbers. So if I make my input years since 1990, then 1992 becomes 2. And when you see the ordered pair 222, you translate the 2 to 1992, not 2 years since 1990. Nobody talks like that. And 1993 and 1994 and so on and so forth, so that our input is more usable. Okay, graph the points. All right, so let's see. I have a lot of variation here. Let's spread this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have to spread it out, but it's nice, easier to read when we have a spread out graph. My data goes from 22 to 51, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. I could go up by 10. It would be fine. And then my data would be pretty spot on. But I could also break my table, meaning it's kind of like I folded the paper and I'm ignoring the bottom row. And instead of the first row being 5 or 10 or 20, I'm just going to start at 20. And then to get up to 50, I'm going to go up by 5s. 25, 30, 35, 40, 45, 50, 55. Okay, now plot the points. So I have 222, so 22 is about there. 324, 24 is about there. 427, 27 is about here, and it's still about there for 527. 634, oops, 634 is about here, 740, 842, 945, and 1051. All right, now when I do my line of best fit, splits the data in direction. So let's start with direction. So I'm going to make sure that my ruler goes into the direction that my data is flowing. A lot of times I'll have students start at 0, 0. That doesn't matter. Probably 0, 0 isn't a point. It's very rare that your starting off point is 0. So we go in the direction, and then because there's 10 points, we're going to cover about half of them. So 1, 2, 3, I've covered about 4, 5 points. So if I draw my graph, I have 1, 2, 3 on top, 1, 2, 3, and 4 on bottom. I go through 1 point. I don't have to go through any points. It's not a bad line of best fit. I'm splitting the data. I'm going in the direction of the data. Those are my two criteria. Make sure to label the x-axis, years since 1990, title the graph, active woodpecker clusters. I'm also going to say over here, number of active clusters. Okay, so now I have everything on my graph labeled, scaled, graphed with a line. All right, so now let's look at what's being asked. Describe the trend you found between the year and the number of active clusters. Okay, well, as the year increases, the number of active clusters of woodpeckers increase. As the input increases, the output increases. That gives us our positive slope. What does the ordered pair 842 represent? Again, this is years since 1990. Don't say 8 years since 1990. Nobody speaks that way. In 1998, there were 42 active clusters of woodpeckers in DeSoto National Forest. Okay. How would you represent 62 active clusters of woodpeckers in 2007? All right, well, it's years since 1990, so I'm going to subtract 1990 to get 17. And then I just have to write the ordered pair, 17, 62. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!